Wait for our recording to start. All right, so our recording is on. We are going to be looking at lesson 5.4, our angles between 0 and 360. So this is a direct continuation of the lesson you just did on your own. And that one's a little bit long, but I didn't want to rush through it because it is hard. So we're going to start by doing a quick review of what the last lesson was all about. So the first thing we're going to do is we're going to state the exact value of tan 225. So in our lesson yesterday, 225 was not one of our special angles, but it doesn't mean we can't find the exact value of it. So when I'm asked to state the value of an angle that's bigger than 90 degrees, the first thing I'm going to do is I'm going to draw a picture. So let's draw our angle. So I'm just going to draw my Cartesian plane. So that's where I'm going to start. And now I'm just going to draw the angle 225. So we start at 0, we go all the way around past 90, past 180, and 225 is going to be living somewhere here, like that. Now, the next thing we do is we find our related acute angle, which is represented by beta. And our related acute angle is always measured from the x-axis. No matter which quadrant you're in, we always measure it from the x-axis. So I'm at 225 to get back to 180 means that this is 45 degrees in here like this. So now what I'm going to do is I can only really find my ratios for angles that are in quadrant 1. So I'm just going to find tan of that related acute angle. Once I have that value, we can use that to find tan of 225. So tan of 45 is actually one of our special triangle angles. So that is equal to 1. We will be using a bunch of those right now. So if you have it with you, I would probably suggest pulling out your special triangles notes from yesterday, just so that you have that list of all of our special angles ready to go, because I'm sure that it's really, you don't have them committed to memory or anything like that, so it will be beneficial. Now that we have tan of our related acute angle, we can find tan of our big angle. So the tan value of our related acute angle and our big angle always have the same number. The only thing that changes about them is the sign. And how we figure out what the sign is we use our cast rule. So our cast rule just tells us which angle is positive where. So if I look, our angle 225 is living in our T quadrant, which means tan in this quadrant is also positive. So I can leave my answer here as positive 1. I don't need to add a negative because tan is positive in that quadrant. So hopefully going through that example helped clear things up from the video a little bit. We're going to do another one to help clear it up further. But are there any questions about that example so far? These do take a little bit to fully understand, but hopefully you're following me at least with my steps as I go along. Okay, so we're going to do example B, because example B is just a little bit different, and it's kind of like the other type of question you can get from our cast rule. So for B here, if point P at 5, -12 is on the circumference of a circle, let's determine the primary trigonometric ratios for the principal angle. So let's start again by drawing a picture. So draw my little Cartesian plane. Sorry, my lines are kind of wiggly. and we'll just do 5, negative 12. It's just a sketch, so it doesn't have to be perfect. So here's my terminal arm. So my whole angle, the principal angle that we're talking about, starts here, goes all the way around, and ends up over here. Now what we're looking for is we're looking for the primary trigonometric ratios of our principal angle. So how we're going to do that is we're going to start by using our triangle, a right triangle, to find our primary trigonometric ratios. So that point is at 5, negative 12. So this is 5, this is negative 12, like that. And now let's find the value of our hypotenuse by using our Pythagorean theorem. So a squared plus b squared equals c squared. So 5 squared is 25, negative 12 squared is 144. So then we'll get 169 equals c squared. And I just want c, so I square root both sides. And I'll get 13 equals c. So on my triangle there, I have 13 right there. So now, because I want to find the sine, cosine, tan values of my principal angle, this big angle here, I need to first find the sine, cosine, tan of my related acute angle beta inside here. So using that beta, let's label our triangles. This is my hypotenuse, this is my adjacent, that's my opposite. And now we can find sine, cosine, and tan. So sine of our angle here is going to be opposite of our hypotenuse, so negative 12 over 13, like that. Cosine is going to be 5 over 13, and tan is going to be opposite over adjacent, negative 12 over 5. Oops, I forgot my little theta there. Sorry about that. So now what I want to do is I just want to verify with my cast rule that I have all my signs correct. So in this quadrant that we're in, C should be the only one that's positive. So cosine should be the only one that's positive. So I look at my answers. Sine is negative. That's a good sign. Cosine is positive. That's good. And tan is negative. So that means I have everything figured out. So those are really the two ways that we use our cast rule. So now what we're going to do is instead of going from my angle to my tan value, I'm going to be given a ratio value and I have to go back to my angle. So that's what we're going to work on. And we're still going to be looking at our angles, looking at our cast rule. So hopefully everything starts to clear up throughout this lesson. Okay, so we're actually going to continue with this example B here. And what we're going to try to find is the value of this angle here. So this big angle here, we want to find the value of that angle. So let's get started. So we are given our trigonometric ratios over here. So what we're going to do is we are just going to use those in order to find our beta. Oops. So here we go. I'm just going to draw it again. So it's down here like this. And I have my little beta in there, and we're looking for this big angle. So all I'm going to do to start is I'm just going to use sine theta is negative 12 over 13. And I just got that from up here because it's the same example, just continued. So now what I'm going to do is I'm just going to put that in my calculator to solve for theta. So theta is equal to sine inverse negative 12 over 13. And I'm just going to put that into my calculator. So when you type all of that into your calculator, we're going to get negative 67.3. And what that negative means is it's telling me I'm going this way. So if you recall from yesterday, a negative angle means it's going in the opposite direction. So it's telling me that here is 67.3. In other words, it's giving me my related acute angle, or my beta. Yeah, Jessica, feel free to type your question or turn your mic off and speak, whatever you're more comfortable with. Where did I get 13? Oh, I just got it from up here. Because I had, because I had 5 and 12. Oops, wrong one. I thought I was on the highlighter, sorry. Because I had 5 and 12, I needed to find 13, so I used Pythagorean theorem. This question is just continuing from the top. Okay. So now I have my related acute angle. So if that is 67.3, how much was it to get from here all the way around? That would be 360 minus that 67.3. Afshal, you can just type your question in the chat, or you can take off your mic and speak, whatever you're more comfortable with. And that means that we have 292.7 degrees. So all I did again was I found my related acute angle in here, and then I figured out how much would have been here all the way around if I only had 67.3 left. Keith, you can type your question too. Afshal, good question. Yeah, I just picked sine. It doesn't matter. You could have used any of them. I just picked the first one. But if you go through and you actually do it with the others, you'll find that you get the exact same angle. So that could be a way to verify that you were correct. So you'll notice that some of the ones through here have a decimal. We probably should have it as a whole angle, but it's okay to have one little decimal place. But you're right, typically we do. If it's something that I'd ever take marks off for, I'd have it really explicitly in the instructions. Any other questions before we do a few more of these to practice some more? No? Okay, so if any come up, just type it in the chat and I will keep an eye out for them. So we're going to go through and do this again, and we're going to do 4 more examples all together, just so you can see lots and lots of examples, because I find that that is the best way to understand this stuff. So what we're going to do is we're going to be looking for the angle. So again, we're given a sine value, a cosine value, cosecant, cotangent, whatever we're given, and we want to find what the angle was before. So let's start with example A here. And A is sine theta equals 1 over root 2. But we don't like to have our root 2 on the bottom. So I multiply both of these by root 2, and I have root 2 over 2. So I have sine theta equals root 2 over 2. So the first thing I'm going to do is I'm going to draw our diagram like this. Go. So we have 0, 90, 180, and 270. So we're going to be plotting some different terminal arms on here. So the first thing we need to do is we need to find our related acute angle. So our related acute angle is always an acute angle. So there's a couple ways that we can find this. When we find our beta, we're just going to do sine -1 of root 2 over 2. So root 2 over 2 is one of our special angles. So you may know that one off the top of your head. However, just for consistency in all of our steps, you can actually put that into your calculator if you want. So if I type that in my calculator, I will get 45 degrees, which is our special angle. So you might be at a point where you see root 2 over 2 and you're like, yep, it's 45, got it, no problem. Or if you want to type it in your calculator just for consistency, that works too. So what that is telling us is that wherever our angle is, it has a related acute angle of 45 degrees. That's the first thing we know. Now, the second thing that we need to know is that in our question here, this number is positive. So sine of whatever angle we're looking for is positive. So now we need to figure out, where is our angle living if sine is positive? So I'm going to use my cast rule. So if I look here, where could sine be living if it's positive? Could be living here, or it could be living over here. There are two choices. So now let's draw angles in those two quadrants that have a related acute angle of 45. So I'm going to draw one in quadrant 1. There it is. And that one, if it has a related acute angle of 45 degrees, remember we always measure our related acute angles from the x-axis, that whole angle is just 45 degrees, right? We measured it right from our x-axis, moved it up, so it's just 45 degrees. So that's our first theta. Now we also could have one living in quadrant 2. So let's draw that one. And our related acute angle must also be 45 degrees. So now I need to think, what is my angle value if it went all the way from 0, went around, and then had 45 degrees left before it got to 180? So I'm just going to do 180 minus 45. So this angle would be 135 up here. So that means that my second angle is 135 degrees. So there are actually two angles that would have a sine value of positive root 2 over 2. Any questions about that one? We're going to do 3 more of these to give you lots of practice. But are there any questions about what we just did? How did I get 135? That's a great question. So my angle goes from 0 past 90 all the way to here. And I know that I have 45 degrees left from there to get to 180. So all I did is I did 180 minus 45 because I need to figure out how far is this part again if I end up having only 45 left to get to 180. That's the idea. So they're kind of like supplementary angles if you want something that you've done before to compare it to. All right, let's try another example. So I'm just going to move this down just so I have lots of room. So B was cosine of theta is equal to negative, and that is 3 over 5, right? Yes. There we go. So the first thing that I'm going to do is I'm going to just draw our little Cartesian plane that I'll be using. So we have 0 degrees, 90 degrees, 180 degrees, and 270 degrees, like that. So the first thing I need to do is find my related acute angle, like that. And how I do that is I'm basically just going to find my beta is going to equal cos -1, and I'm just going to use positive 3 over 5 because my related acute angle is an acute angle, so it should always be positive. So what we do is we take the inverse of the positive version because the sign here is just going to tell us where it lives. So when we're doing this part for our related acute angle, we're going to use positive. Yeah, Dimitri, you can type your question. Okay, so I'm just going to type that into my calculator and I will get 53 degrees. So the beta is the symbol that we use to describe our related acute angle. And that is a symbol, that little beta, that is used like conventionally in math. So if you take grade 12 functions, if you're ever doing stuff like this in post-secondary, they'll always use a beta to describe their related acute angle. So that's why we're using it. So I don't know who decided beta, but that's what they decided. So just for consistency, I want to make sure that if you saw beta in this situation, you know what they're referring to. All right, so we have a related acute angle of 53 degrees. Now we need to figure out, where does our angle live? So it is negative over here. Cosine of our angle is negative. So let's figure out where that could live. So where is cosine negative? It's negative over here, and it's negative over here. So our angle is living in those quadrants. So now let's draw some angles that have a related acute angle of 53. So there's going to be one up here. And remember, our related acute angle is always measured from the x-axis like this. So this purple angle has a related acute angle of 53 degrees. So now let's find the value of this angle. So my angle starts at 0, goes all the way over to here, and then there's 53 left to get to 180. So I'm just going to do 180 minus 53, and I will get that this angle is 127 degrees. So that's our first one. And now we need to find our second one, because it could also be living in quadrant 3. So let's draw out our angle. There it is. And these aren't going to be exact. I'm just kind of drawing it in quadrant 3 somewhere. So if it's not exact, it's just because we're doing a little sketch. So again, this angle also has a related acute angle of 53 degrees. And remember, we always measure our related acute angle from the x-axis. Sasha, you can type your question or turn off your mic and speak, whatever you prefer. Yeah, sure. So if I look here, in the question that they gave me, cos is negative here. So that means it has to live here or here, because those are the only ones that have a negative cosine. Does that make a little bit more sense? Yeah. Dimitri's question is the 127 the whole purple angle again? Yes, it is. So the 127 goes from here all the way to here, right? So we had 53 left to get to 180. So here I go past 90 to 127. And then I would only have, oh, it's thought I was drawing a circle. And then I'd have 53 left to get to 180. So this whole thing is 127. So let's find our second one. I'll put it in different colors so you can see. So what we're going to do is, to our second angle in our third quadrant, we start at 0. Oops, that's way too big, sorry. We start at 0, past 90, past 180, all the way to here. Why does it keep thinking I'm drawing shapes? All the way to here. So now let's find the value of this angle here. So we went past 90, past 180, and once we passed 180, we went an additional 53. So I'm going to do 180 plus that additional 53 of our related acute angle. So that would give us 233 degrees. Now there is a nice way to check your answers here. which I think is really beneficial. If I put cosine of 127 into my calculator, so I'm just going to do that, cosine 127, I get negative 0.6018. If I do negative 3 divided by 5, I get negative 0.6. So that extra decimal is just a little bit of rounding error there, but I end up getting the same answer by doing this as I do looking here. So there is a way to check your answer. Unfortunately, if I try to use my cosine inverse and go backwards, it always just gives me my related acute angle, not the real angle. But there is a way to check your answer, which I think people always really appreciate. Okay, let's do the other two examples together so that we can have a little bit more practice. Okay, so let's move on to C. And C is cosecant of theta is equal to negative 2 root 3 all over 3, like this. So we're going to approach this the exact same way that we did the other ones. So just so we have it, I'm going to draw out my Cartesian plane, 90, 180, 270, like this. And now I need to find my related acute angle. Now the tricky bit is I don't have a cosecant button on my calculator. So that means I'm going to have to find everything for sine. So I'm going to switch this to sine. And when we switch it to sine, we just flip our fraction. So we're going to have negative 3 over 2 root 3, like this. And I'm just going to leave the radical on the bottom for right now because it doesn't really change anything when we are finding our theta. So let's start by finding our related acute angle. And remember, when I find my related acute angle, I don't need this negative here. That's just telling me where the angle lives. I'm just going to use the positive one, so I find the related acute angle. Can we use tan and cotangent too? We will be doing that for example D. So because the example gave me cosecant, then I have to use cosecant and sine. And in my next example, it uses cotangent, so then we'll use cotangent and tangent. Yes, so because it's cosecant in this example, it's only cosecant and sine. It has to be. Other question, Jansen asked, how would you solve for angle if you only had a decimal number instead of a fraction? I can show you that after we go through this. I think, if I remember correctly, I think you emailed about that and I sent you a solution too. But basically, we just flip the fraction like this. But I can go over it after this lesson too in a ton more detail. But I think if I do it right now, it might confuse some people. Okay, so let's find that related acute angle. So my theta is going to be equal to sine inverse of this thing. And remember that we use the positive one, again, to reiterate, because this negative thing is telling me where my angle lives, but the positive version will give us my related acute angle. So I'm just going to type that thing into my calculator, and it is actually one of our special ones. So if you are able to catch that right off the bat, awesome. But if you end up typing into your calculator, oops, this should have been my beta because I'm looking for my related acute. It will give us 60. So that is one of our special angles. But if you type in your calculator, you get the answer too. So that's okay. So now I know my related acute angle is 60. And now I need to figure out where my angle lives. So let's look at my cast rule again. So because sine and cosecant are negative, it is going to live here and here, right? Because in this quadrant, sine's positive, so it can't live there. In this quadrant, sine is positive, so it can't live there either. Jansen, no. You could just have jumped, like you could have said, find that and just jump to here. That's fine. So let's draw our angles. We have one living in quadrant 3 here, and it has a related acute angle of 60 degrees. So remember that our related acute angles are always measured from the x-axis. So let's find our angle. It goes from 0, past 90, past 180, all the way to our angle, which is 60 degrees past 180. So 180 plus that extra 60 degrees is going to get me to 240 degrees. So that's my first theta. And now we have a second one because we also have one living in quadrant 4 here. And again, this one also has a related acute angle of 60 degrees. And our related acute angle is always measured from the x-axis, no matter what. So let's find that angle. So again, we start at 0, past 90, past 180, past 270, all the way to here. Oh, thinks I'm drawing a circle again. And yeah, Ethan, you can type your question. And where I end up is 60 from 360. So 360 backwards, 60 degrees. So this would be 300 degrees. Ethan's questions. How did I get 240? So to get 240, okay, I'm going to address Ethan's and then I'll address Jansen's question. So how I got 240 was my angle starts at 0, passes 90, passes 80, sorry, passes 180. Once it passes 180, I go an additional 60 because of that related acute angle. So again, we go 90, 180, plus an additional 60. So how I got 240 was I did 180 plus that additional 60. Similarly, for my other one, I go from 0, past 90, past 180, past 270, and I get all the way to here. Now I know that that angle is 60, this is 360, and I go back 60. So I end up with 300. So that's where those numbers came from. It helps to have it on the graph and kind of visualize it a little bit like that. Jansen, how did I know that it would be in quadrants 3 and 4? How I knew that was because my answer is negative here. So see how I have negatives here? Because of my cast rule, sign is negative in the C quadrant and the T. So it has to be living there. Ethan had a question. What angles did you get in B? This one's done in the previous question. We got 233 and 127. So same idea here. When I'm finding my angles, I just go from 0 past 90 to here, and I know I have 53 left to get to 180. Okay, any other questions before we do our last example? Okay, we'll do one more, and then if you guys have other questions, I'm more than happy to address them further. Okay, so now D is cotangent of theta is equal to negative 2.153. So I think, Jansen, this will also answer your question from before when you were asking about these decimals. And this was actually a really common question that I was getting a lot. So I actually think this is really beneficial for everybody because I had quite a few people asking me how to do this because it just doesn't really seem to fit, and you don't have a cotangent button on your calculator. So when we're given cotangent for these, we don't have like a cotangent button to figure out what our related acute angle is. So we're going to have to use tan. So I'll show you how to do that. So we'll find our related acute angle. So again, we do not have a cotangent button, so we need to switch this to tan. And because cotangent is 1 over tan, if I want to go back to tan, all I do is I just put this on the bottom of a fraction. All I do is there's a 1 under here. All I do is I just flip that. Yeah, Dustin, you can take your question. So that's all I'm doing is I'm just flipping this fraction, just like you would have before, but we have a little 1 under there. So I'm going to simplify this tan theta here, and that will give me 1 divided by negative 2.153. Oops, my calculator is dying and turning off. That will give me negative 0.4645. What is the use purpose of the reciprocal ratio? You will see what their purpose is shortly in our next lesson. We're going to get into doing some proofs and stuff like that, and they are actually very beneficial when we get there. The other piece where they're beneficial is sometimes it does make long algebraic expressions a little bit easier when I have different things on the numerator and in the denominator. Furthermore, we are going to get into, in our next unit, we'll get into graphing these things. And when you graph these as a function, then having their reciprocal version ends up just being its own separate function, which can model some real world relationships. So that's why right now they seem really random. But once we get to next lesson and unit 6, you'll see why we even use these things or why they're a thing. Ethan's question was, how did I get the negative 0.4645? I just put this thing into my calculator. So I just did 1 divided by negative 2.153, and I got this thing. So that's where that came from. Okay, let's find our related acute angle. So my beta, again, remember that we do not use the negative, we can just use the positive part. So we're going to have tan negative 1 of 0.4645. And that will give us about 25 degrees. I am rounding a little bit here, but that's okay. We'll round to the nearest whole number. So my related acute angle is 25 degrees. Now we need to figure out where these angles are living. So I look at my cast rule, and I notice that tan is negative, right? Because of that little negative, we know that we are either living in this quadrant or in this quadrant. And again, that's because our tan value is negative, so it must be living in the C quadrant or in the S quadrant. So now let's draw some angles. So we have one in the S quadrant here, and we have a related acute angle of 25. So remember, our related acute angles are always measured from the x-axis. So now let's find the value of that angle. So we go from 0 plus 90 and plus a little bit. And then we would have 25 degrees left to get to 180. So 180 minus that 25, that angle is at 155 degrees. So theta 1 is at 155 degrees. Now let's find our second theta, because I also have one living over here. So again, over here, my related acute angle must also be 25 degrees. So now we can find our values. So I go past 90, past 180, past 270, all the way to here. And I would have 25 degrees left to get to 360. So 360 minus 25. So this here would be 335 degrees. So that is my second theta. And that is our last example. Are there any questions before I send you off to do some homework? Yeah, Dimitri, feel free to type your question. Once I answer Dimitri's question, Jansen, I'll talk about attendance in the end of the day, what the plan is. So Dimitri said, how do you know the quadrants to add to the graph? So our quadrants always go from our CAST rule, C, A, S, T, no matter what. So depending on where it's positive, that's how I know which quadrants to go to. So the only ones that are positive in this quadrant is cosine. All of them are positive here. Only sine is positive here, and only tan is positive there. So that's how I know only to add C and S, because tan is negative in those quadrants. Ethan had a question. How are you supposed to know when to add and subtract? So because my values are always measured from my x-axis, I want to look at this in terms of the whole picture. So if I go from here, if I go from here to here, and I have 25 left to get to 180, if you go and add 180 plus 25, you're going to end up with 205. And 205 is in this quadrant. It's not in here anymore. So that's a sign that you've made a mistake. So if I look here, I went from 180 to here, and I still have 25 left here. So I'm going backwards from 180. That's telling me I need to subtract. So that's kind of the idea. Think about where it is. So make sure you're drawing a picture. I think that addresses Tony's question too. Afshal, we can review some homework once our questions about this lesson is done. Okay, so I'm going to stop the recording here so the video isn't too long.